Perfect. So we are EVBN, the first virtual blockchain. So I'm gonna give you a small description about how the EVBN works, how you make your own EVBN, and how you make your own service. So it's gonna be quick, like deploying your own EVBN. So let's get into the process. You first need to go to evbn.info and go to the GitHub. In the GitHub, you're gonna find all the repositories. The repository for deploying your own EVBN gonna be testnet contracts. So you need to clone that contract, and after this, you can set up some stuff. You can find it on evbn.info if you find it in the quick start, and you're gonna see all the process for deploying your EVBN. After this, it's just simple. You only use npm run wizard. After this, it's gonna ask for your admin address. So I'm gonna use my address right now and deploy it. So gonna ask for my golden fisher address, gonna ask for my activation address, and they're gonna ask for my EVBN name. So I'm gonna be quick in this part. With EVBN, you can deploy your own virtualized blockchain and any blockchain you can imagine. So any EVBN compatible blockchain, you can deploy it and you can configure that virtual blockchain as you wish. And you can see you have the EVBN name. For this example, you're gonna put I don't know, ETHGlobal. We're gonna put the principal token name. So the principal token name is in charge for the staking services and the reward services. So when you interact with EVBN, any transaction you make, you give a small reward for your execution. So in this example, you're gonna put the token principal name, gonna be global, and the ticker gonna be GLP. Okay, so they asked you about the advanced metadata. Just for a quick summary, the advanced metadata can be the total supply of tokens around the EVBN, the ERA tokens, and the reward. After this, it's just simple. Press yes again, select your network. In this case, you can put Ethereum Sepolia or Arbitrum Sepolia, but you can add your own RPC custom. So you can deploy everywhere. So in this example, we're gonna deploy on Ethereum Sepolia. They ask about our wallet. So right now we are compilating. Takes a little bit. So while we're waiting, compiler is successful. Okay, so they ask about the private key. So we're gonna put my password, sorry. And right now we're deploying their own EVBN. So while we're waiting, let's talk about the services. So the services is the most simple thing. So it's a smart contract you can connect with the EVBN. In this example, gonna be two. The backend is gonna be the smart contract and the front end. So for the contract, you can go to the GitHub repositories, and you can find the Hackathon coffee shop example. So for this part, gonna be this. So you need to declare some variables, some simple variables, and the interface for EVBN. You can find us on npm. If you want to deploy, for example, in Hardhat or Remix, you can do that too. And after this, we declare the libraries, so the EVBN, and the staking address. After this, it's just simple. So we have the simple input variables. It's gonna be the name of the user they want to transact this order coffee, the type of coffee you want to use, the quantity, the total price, and the nonce. The nonce is the most important part. So because of the transactions go signed by RC101, and the input's gonna be sent through the phishing spot, you need to use the nonce just for don't duplicate the transactions. After this, you put the signature. I'm gonna talk about later about the signatures and some stuff for the EVBM because it's a payment system. So we have the priority fee. This priority fee gonna be the fee for the fishers for executing that transaction, the nonce for the EVBM, the priority flag. If you put true, you're gonna be async nonces, and if you put false, you're gonna be synchronous nonces. After this, the signature for the EVBM, and after this, gonna be the logic. So if you see, they have this format for the EVBM. They have the EVBM ID, the function name, and the inputs. All gonna be on the string. So they have this library called signature verification. You can find this too on the npm. And the only thing you need to do is you put your EVBN ID, the function name, and a string concat about all the inputs gonna be inside. After this, we check about the the nonce in the service and the payment process. So one interesting thing, if you see in the IEVBM, you're gonna find the from, the who is gonna execute the transaction, the to, who is gonna send the, in this case, the ether, can be an address, can be an identity, the token you're gonna use, the amount you're gonna send, the priority fee, the nonce for the ABBM, the priority flag, I talk, the address, and the signature. So one important part is the executor. Think about as a voucher. So for this example, the only transaction can be executed because of that. It's only the service, the EVBN cafe. But if a fisher tries to execute that and has a different address than the service, the system gonna revert and you can execute that payment. And we have a verification for this, the address staker. One interesting part of the EVBN is that as a simple account can be a staker, but a service too. So a service, a smart contract, can receive rewards and can receive the priority fee of that execution. And if you are a staker, well, you can program that rewards or distribute them. So in this example, we distribute all the priority fee for the fisher, and this part, we're gonna distribute the half of the rewards given for that payment to that fisher. And after that, we just check the nonces and verify it's all correct. And if you want to stake as a service, you have two options. Use our library to make more simple execution, or you can follow this step for making that staking process. And for the on stake, it's just simple. Just this part, and after this, you put the service on staking. And for the front end, it's gonna be pretty easy. So if you go to front, sorry, you go to the components, cafe component. Right now, I don't have the npm installed, so it's gonna be a little bit of problem. But if you go to make sig, you're gonna find all the process to make that signature. So it's pretty easy to follow. And let's check it out about our registration. So right now we deploy our EVBN instance. So we're gonna register that EVBN. It's important to register that EVBN because you only have one unique ID. It's the same as, for example, the chain ID. So if the third more simple way is just to not confuse one EVBN to another. So we verify, we send it to the registry, and after that, we register inside the EVBN. We're waiting for the confirmation. Right now, the internet is a little bit slower, so that's it. You have your own EVBN instance ready to use. And that's it from my part. So right now, we're going with Oucan. They have figured out how to develop a service or a front end for Vibecoders.
Perfect. Can you hear me? Okay. So the interesting part about EVVM is that you can build services on the top of it. So we're not complicated a lot. I'm a Vibecoder. I know that most of you are hardcore OG developers. So I want to tell you how to create a new service using only AI. So we have our full LM text link that we will provide to our IDE with, for example, Claude. That's what I have right here. I'll just, yeah. So it's not that one. Don't worry. We'll put the other one. So yeah. So I'm telling my AI agent to create a new service on the top of EVVM using the LNM full context. So it will create a smart contract that works as a faucet of USDC. Okay. So I just click enter, and it will analyze the documentation that I provided. And just to prove how it worked, I already created a app that was made with vibe coding, and I can show you that that will be kind of the result you will have when talking to our full LM text file. So I told the AI to create a faucet where you can claim PayPal USDC, PayPal USD, and here you will um, look how looks EVVM dApp. So as Kevin said before, for connecting your front end with your smart contract, you have to use our signature NPM package. And for example, I'm going to click on my dashboard, and I have some PayPal USD already, but look how works gasless transactions. So I'm going to faucet, and here we have required gas, but we are not in that times using gas now. So we are going to claim PayPal USD. So let's claim. I have to put my. Um, and as you can see, I'm signing a transaction. I'm not paying any gas for a gasless transaction, obviously on EVVM. So I already claimed, and I still have 128. So let's refresh and see how fast it is. Well, um, till it. Oh, here you have it. So gasless transactions, I just received PayPal USD, and look how the AI is working on the new contract for. Um, I didn't give it there. Yes, on a scan. So you have to let your AI agent to fetch data from the links we provided, and just look at the results. So you can create smart contracts that will work with EVVM in a gasless way using the AI documentation we have, and obviously the NPM package for the signature construction and execution. So let's see how it. I still have like 1 minute, and it will result in a smart contract that works as a faucet for providing USDC to any user in a gasless way. So if you have questions, it goes. Go ahead. Do you have any question about EBBM? No one? Any questions? Like, just to be clear, you can deploy an EVVM in the top of any blockchain. So here we have, for example, Base as a sponsor. So you can use Base chain and deploy your EVVM on the top of Base. So there you will have two prices secured if your product is really innovative and touches our tracks and obviously Base tracks. So I really recommend you to save time by coding and just look at what I built like 1 month ago. It's a fully working service on a gasless way. I can also claim. Let's go back to this. So look, with the full documentation link that I provided to Claude, the AI agent has all the knowledge needed for creating event-less contracts, but state updating contracts. So you can create a smart contract using our LLM documentation, and obviously you have to check it, you have to prove it, you have to run some tests on it, but it is what it is. Like 1 minute or less smart contracts for gasless transactions. Do you have any questions at this moment? Like, I really enjoy giving that kind of. Oh, here you have it. So yeah, we are creating a gasless faucet with only one prompt, giving and providing the context links. Any questions? Gasless transactions. Just remember it. Who is going to pay the gas on your applications? Be aware of that. If your sponsor is running out of gas, your DApp is dead. That's it. It's the only argument I'm going to provide you. And thank you for your attention. And just look at it. How we're creating a smart contract with its own README for a gasless faucet. Thank you. Thank you a lot.